Hello students, welcome back to our channel Diksha Karnataka. So as we have already know, we are solving 30 important questions from all the high weightage topics. So in today's video, we will discuss one of the major topic, that is coordination chemistry, and we'll be doing top 30 questions from this chapter. The questions asked in the KCET exam are very much similar to these questions. So if you are able to do these questions, you can assure that this chapter is ready for your exam. So let us see the first question. So I'll be telling you the right approach to solve this and how can you solve it in a less time. First question is the complex of hexaamine platinum 4. Okay, the compound name is given to you. Chloride will give dash number of ions on ionization. So this part comes from your Werner's theory, where it tells about primary valency and secondary valency, ionizable, non-ionizable. But the trick here is how correctly you are writing the compound name. Okay, so first of all, platinum hexaamine, platinum is there, right? So we first need to write the structure correctly. Okay, and Cl is there. Now see here, the platinum is in +4 oxidation state. Okay, and chlorine is in, we know the oxidation state of chlorine is -1. So that means, and they have given you the complex having dash number of ions will be produced on this one. Now you have to check this compound must be +4, right? That then only we'll get platinum as +4. Like for example, we don't know the platinum oxidation state here. So see here, this one is X and NH3 is neutral ligand. 6 plus into 0 should be equal to +4. Then we will get X is equal to +4. Then platinum is +4, which is given in the question, right? So that means this complex is +4 and here it is chlorine is -1. So if we do crisscross, we will get platinum NH3 whole 6 Cl4, right? Just by crisscross method. So now you see, if you ionize it, we'll get 4 chlorine ions and 1 ion of this complex. So the total number of ions formed is 5, and the correct answer for this question is option C. Now let us go to the next question. Again, very similar to those questions. Addition of excess of AgNO3 to an aqueous solution of 1 mole of PdCl2 dot 4NH3. Okay, what is the compound? 2 moles of AgCl is produced. That means 2 chlorine should be outside. Okay, so we can write down this one as PdNH3 whole 4 and Cl2, right? So 2 chlorines of 2 moles of AgCl. So if we have 2 chlorines outside, we'll get 2 moles of AgCl. Next, the conductivity of this solution corresponds to. Okay, so what is this conductivity? How to find out this one? So it is just like how many cations are there? Ratio of cations to anions, right? So you see this one is cation and this part is anion. We have 1 cation and 2 anions. So I can write 1:2. Okay, so the correct answer for this is option C. Now let us see the next question. How many ions per molecule are produced in the solution when more salt is dissolved in excess of water? So this question is easy only if you know the formula of more salt. Okay, so more salt formula is NH4 whole 2 FeSO4 whole 2. Okay, so the total number of ions we will get is 2 times of NH4 plus 1 Fe, and then we will get SO4 2 minus 2. So the total number of ions produced here is 5, and the correct answer is option A. So you can see so many questions are asked only from primary and secondary valency. So you should know this concept of ionization and non-ionization. Okay, now next topic is important definitions. Some questions are related to definitions. We'll see. Homoleptic complexes among the following is. So this question you can do only if you know what is a homoleptic complex. The ligand should be same. All the ligands should be same. So here you see all the 3 ligands are C2O4. So this is a homoleptic complex. Here you see we have 2 different types of ligands. So it is a heteroleptic complex. And here also we have 4OH, that is a homoleptic complex. So the correct answer for this question is option C, that is 1 and 3 only. Okay, next. The coordination number, okay, of Fe and CO in the complexes are. So this question is little difficult if you don't know the denticity of the ligands. You should know C2O4 is a didentate ligand and SCN is a monodentate ligand. Now if Fe C2O4 3 times is given, right? That means we can write like this. Okay, this is the structure. So I'm not doing the complete thing, but C2O4. So what is the like how many bonds are there for the metal? 6. So first will be 6, and then for CO, SC and 4. We have 4 ligands, so the coordination number will be 6 and 4. Okay, so there will be, you may do mistake in this option 3 and 4, right? 3 and 4, because you can see that there is only 3 ligands, but you should know it is a didentate ligand. Each ligand forms 2 bonds, so 3 ligands will form 6 bonds, right? So the correct answer for this question is option C. This was the option where you could have done mistake if you don't know this concept. Okay, next. Which among the following is the strongest ligand? Okay, so strongest ligand, I have told you the spectrochemical series you should remember. So from that, the correct answer is option C, CO group. Okay, so this is direct question, you have to know. So no need to remember the full series. Remember the first, like top 4 and the bottom 4, right? Okay, next. Coordination number of the oxidation state of the element in M, you have to find out the oxidation number. Okay, so oxidation number, very simple, you have to just find out, let it be X. En is a neutral ligand, so it will be 0. C2O4 is a 2 minus ligand, right? So we can took NO2 is -1, means this one is +1, or we can equate here also. Okay. So you can see here, this one we got NO2 is -1 is equal to 0. So X is equal to +3, right? So what's the oxidation state? Oxidation state is +3. So we can have these two options. We can eliminate these two options. Now coordination number is very easy. You know En. En forms again 2 bonds, right? So 1 En will form 2 bonds. So 2 En will form 4 bonds. And then 1 C2O4 also forms 2 bonds. So 1 C2O4 will also form 2 bonds. So total number of ligands or total number of points will be 6. So coordination number is 6, oxidation number is 3. Correct answer is option C. Next. Okay, so one of the major topic, isomers. You have to learn about geometrical isomers and stereoisomers. COEN2Cl2. This is one of the very important example. COEN2Cl2. So first of all, it can have this trans geometry. Okay. Then we can have the cis geometry here. Okay. Now you can see this cis geometry can also have an see, they have not mentioned like is it not optical here, only told the stereoisomers. So this is all you have to take it. You can do Cl, then we have En, and then this side we have En, right? So both the mirror images are non-superimposable, and so total number of isomers is 3 in this. Option C is the correct answer. Okay, next. This one will show which type of linkage which type of isomerism, right? So you can see NO2 is there and ONO is there. Ambidentate ligands are there. The possibility is linkage isomerism. Correct answer is option A. Okay, next. Square planar complex of MAXBL type can show which type of isomers. Okay, so see here. MAXBL. Okay, these all are different groups, right? So this is one possibility. You can have LB here, and one more is, okay, so you can see this 2 type is your cis geometry, we can say, because AX are on the same side, and this one is your trans geometry. AX are your opposite side. You can compare anything. Okay, so all the 4 are unidentate ligands, so you can take any one combination and check. So we will get 2 cis and 1 trans. Okay, so the correct answer is option A. The number of isomers possible for the octahedral complex given to you. Okay, so you can see all the isomers we can draw here. We have Cl, we can draw like this, then NH3, and then we have En here. Okay, this is one geometry. Then we can have CO, Cl, NH3 I can take here instead of trans with respect to NH3 we can do, right? And then Cl we can have En here. Okay, next one, what else possible is we can take NH3 and Cl in this form. without any cis and trans, we can just take one NH3 and one Cl. Okay, then we can get this one, right? So this compound, if you take the mirror image of this one, that will be non-superimposable. So total isomers we'll get is 4 isomers, right? Okay. So next, which of the following will show geometrical isomerism? So tetrahedral compounds do not show geometrical isomerism, and square planar of MABCD type shows geometrical isomerism. So this is also not correct. So the correct answer is option C. So you have to remember, in square planar MABCD, this type will show your geometrical isomerism, and MA2B2 will show, but MA3B will not show. Okay, so this answer is option D. Next, which formula and name combination is incorrect? Okay, so very simple one. Let us see quickly. Aluminium oxalate, incorrect, we have to find out. Okay, so potassium is there, then aluminate is there because it is a negative term. Trioxalato, and this part, yeah, this is also correct. Now let us see the next one. You can see diamine, then we have chlorido, that is correct. Nitrito, yeah, nitrito N is also there, and then platinum is there, and platinum 2, right? This is also correct. Next, if you check here, we have dichlorido, correct. Diethylene diamine, okay. Then we have cobalt 3 chloride, okay. First, let us check the fourth option. I think this can be incorrect. I'll tell you the reason. Here we have tetraamine, okay. Then we have aqua, then we have chlorido, and then cobalt 3 chloride. Yes, this is also correct. But here you see, this is ethylene diamine, this di will not come, right? I told you the name for EN and for EDTA, we use the word like bis, tris, right? So we have to use bis instead of di. So that is why this option is incorrect. So the correct answer for this question is option C. Okay, next, cisplatin. Cisplatin, what is the structure? PT, NH3 is on the same side, okay, and we have Cl on the same side. So you can check here. First is diamine, dichlorido. This is incorrect. Okay. Here we have also, we have to just check the oxidation state of platinum. That is 2. So only one option is there, and this is also alphabetical order. So the correct answer for this question is option C. Okay. Next, the IUPAC name of this one. You can see a lot of questions are asked from IUPAC name. So properly revise the rules and practice more number of examples. So here we have first is pentaamine. You can say the ligand should be named alphabetical order. So this name is amine, this name is carbonato, right? So that is why we have to use first pentaamine. So you can delete this option. Now pentaamine is there, pentaamine is also, these 3 options we can check. Next we have carbonato. So this is carbonato, this is also carbonato. Here there is no, this carbonate is at the end. So this is wrong. Okay, we can eliminate option D also. Next, what else is there? Cobalt. So what is the oxidation state of cobalt? You can see X. The NH3 is the neutral ligand. Carbonate is -2. This is -1 is equal to 0. So this is equal to +3, right? So out of option, okay, this is also +3. This is also +3. Okay, then what is the difference? This is cobalt. This is cobaltate. When do we have to use the word cobaltate? If it is a part of the anionic complex. You can see this cobalt is a part of cationic complex, so the name should be cobalt, not cobaltate. So the correct answer for this question is option A. Okay. Next, again IUPAC name of the compound. Okay, let us, in this type of question, so it is little tricky to find the oxidation state. Let the oxidation state of platinum be X. Ammonia is neutral, so 0. Then again this is X. This is -4 is equal to 0. So I can write 2x is equal to +4. So x is equal to +2. So I can say platinum is in +2 oxidation state. So this option we can eliminate, this option we can eliminate. We have this one and this one. Okay. Now you see this part is cationic complex and this part is anionic complex. And cationic complex should be named first, and platinum here should not be platinate, right? The name here is platinate. But here it is platinum and here it is platinate. The anionic complex should be platinate. The cationic complex should be platinum. So the correct answer for this question is option C. Okay, very simple and easy one. The only trick here is to find the oxidation state correctly. Okay, next. Okay, next again, penta aqua, you have to tell the formula for this one. So when you write, see, when you write the nomenclature, first ligands will come, then metal will come. But when you write the formula, first metal will come, then ligands will come. So we need chromium, right? Chromium metal, then we have penta aqua, so H2O5. So we can eliminate this option, you can see, we can eliminate this option, okay? Then we have nitrato, okay? Next, outside we have nitrate, right? Now you see how to check the oxidation state. You see here, this chromium oxidation has come, let it be X, this is -1, and here it has, if we take like this -2, we will get chromium as +2, right? But that is not the case, right? But if you see the option and we make it 2 as given in this option, then how we can check? We can check like this, right? X -1 here and -2 here, that is equal to 0. So X is equal to +3, which is the given in the name. So that is why the correct answer for this question is option C. You can also eliminate in other way. You can see this is not nitrate, right? This is nitrito, right? The name is different. So from that also we can eliminate, or you can check the charge also. Correct answer for this question is option C. Next. Okay, again we have IUPAC name for this one. See, first of all, we will write the ligands and in alphabetical order. So first will come, amine will come first, right? All the options are having amine, so we cannot eliminate anything. Next will come chlorido. So all the options are also having chlorido. Next we have nitrito, right? You can see here nitrito N is there. Here only nitrito is there. It is not mentioned N or O. Here what is the problem? Here also nitrio is written something different, and here also the spelling is wrong. So this is nitrito N cobalt 3 chloride. Just we can once cross check the valency, the oxidation state. So X -1 is equal to 0. We'll get X is equal to +3. So the correct answer for this question is option A. Next question. Okay, the name of the given compound. Again, we have on IPSC name, you have a lot of questions from nomenclature. Please prepare them thoroughly. So let us see here. We have first option is, you can see chlorido. Here chloro is there, and here chlorido, here chloro. You know the name should be chlorido. So we can eliminate this option and this option. Next, for ethene, bis has to be used, right? Here it is di. We can eliminate this option also. Correct answer for this question is option A. Okay. Next, CFSE. Which of the following has the maximum number of unpaired electrons? So this is coming, you have to know how to write the electronic configuration. D9. So high spin, low spin is applicable for D4 to D7. D9 is same in both the cases. What will be the D9 configuration? T2G6 and EG3. Number of unpaired electron here is 1. Now D6 low spin. Low spin means again we will get T2G6, right? You know what is low spin? See here. Low spin means all the 6 electrons will be paired up. So I'll get 1, 2, 3, 4, 5, 6. So T2G6, number of unpaired electrons is 0. Now coming to D4 low spin. So if we have D4 low spin, again I'll fill here. Okay. So 1, 2, 3 and 4. Right? D4 low spin. 1, 2, 3 and 4. Low spin means pairing will take place. So number of unpaired electrons here is 2. Now D7 high spin. So D7 high spin, for that, see here, if you want to do D7 high spin means there should not be any pairing. So 1, 2, 3, 4, 5 and 6 and 7. So number of unpaired electrons is 3. So the correct answer for this question is option D. Okay. Easy question. Okay, this one is one formula based question. We know delta T is equal to 4/9 of delta O, right? Now the crystal field splitting energy for COCl6 means delta O is given. Coordination number 6 means octahedron is 18,000. You have to find for COCl4. You have to find for tetrahedron. So delta T is equal to 4/9 of 18,000. So we will get 8,000. Right? Very formula based question, direct formula. But the point is, generally we people don't study this formula more. So just keep in this mind. I have also referred to this formula in my that important topic coordination video. Please make a note of this formula. Very simple and easy to apply, can give you a very good mark. Okay, 8000 is the answer. Okay, now theory based question. Crystal field splitting in octahedral complexes. Okay, so we know what happens here in octahedral complexes. We will draw the diagram, right? This one is 3 by 5 and this one is 2 by 5. So energy increases by 3 by 5 for EG and energy decreases by 2 by 5 for T2G. So let us see the option. The energy of EG orbitals will decrease, EG orbital will increase. So this option is incorrect. Energy of EG orbitals will increase by 3 by 5 and the energy of T2G will decrease by 2 by 5. Yes, this is a correct statement. So the correct answer for this question is option B. Okay, next the wavelength absorbed. Yes, this is very conceptual question. What is the concept here? See, if splitting is high, in case of strong field ligand, high splitting, if splitting is high, then what will happen? High energy wavelength will be absorbed, wavelength will be low, frequency will be high. We know wavelength and energy are inversely proportional. So this is the condition. Now you see we have first option we are having NH3 5 ligands, second option we are having 6 NH3 ligands and third option we are having 6 Cn minus ligands. So if you know the order, the strength, Cn minus is a stronger ligand than NH3, right? So that means here the splitting in option 3, I can draw the diagram like this. This is the option 3 splitting, and if I next which one will come? See here all the 6 are strong ligands NH3, but here one Cl is there. So I can say here splitting will be less. So for option 2 this will be the splitting and for option 1 this is the splitting. So we have to tell the order of the wavelength. So here because the energy is high, okay, wavelength will be minimum, right? And here the wavelength will be in between and here the wavelength will be maximum, right? Because energy is very less, so wavelength will be maximum. So we have to arrange in the order of wavelength. So the correct answer 1. In 1 the energy is less, right? Less energy means high wavelength. So 1 will have the highest wavelength, then it will come second and then it will come third. So the correct answer for this question is option A. A little I'll tell this question is tricky if you haven't understand. Once again I'm repeating the concept. When the strong field ligands are there, splitting is more, then high energy will be absorbed. High energy means low wavelength. If splitting is less, then low energy and high wavelength radiations will be absorbed. Okay, next question. ML bond, this I have also discussed, that is purely ionic. Okay, it has to be purely ionic based on the assumptions. Next question is you have to arrange in the spectrochemical series. Okay, as per the spectrochemical series. So we know the ligands, these are weak field ligands, we can eliminate them. Okay, here SCN and F minus, generally halogens are very weak field ligand, but fluorine comes little like after chlorine, bromine, SCN, then fluorine will come. So the correct answer for this question is option A. Okay, next. Complex having minimum magnitude of delta O is. So delta O minimum when it will be? When the splitting will be least, when the ligands are weak field ligand, right? So we know NH3 is a strong field ligand, Cn is a strong field ligand, water comes in between, chlorine is a weak field ligand. So if there is a weak field ligand, the splitting will be minimum. So the correct answer for this question is option D. Okay, next. Okay, you have to tell me the correct statement here. Okay, let us see here. CONH3 is paramagnetic. Okay, so if you see the cobalt configuration, it is 4s2 3d7, right? Now in this case the oxidation number is 2 plus, so I will get 3d7 as the electronic configuration. 3d7 will have 1 2 3 4 5 6 and 7. We need 2 empty orbitals, right? So if you want to empty 2 orbitals, you can pair up this one, okay, and this electron is sent to the last one, right? So the hybridization is D2sp3 with one unpaired electron here, right? So this is 4s, this is 4p, but this one is 4d containing one unpaired electron from here. Okay, so this statement is correct. MnBr42 minus is tetrahedral. You can see this is a weak field ligand, right? And 4 coordination number weak field ligand or 3D element will generally be tetrahedral. This statement is also correct. COBr exhibits linkage isomerism. We have already discussed for linkage isomerism we need ambidentate ligands. Here there is no ambidentate ligand, so this is a wrong statement. NiNH3 whole 6 2 plus is an inner orbital complex. We can check this one. What is the oxidation state of nickel? Here 2 plus. So the configuration is 3D8. Now if we draw the 3D8 for this one, 1, 2, 3, 4, 5, 6, 7 and 8. Now if you do pairing here, right, then what will happen? Still we will get only one unpaired or only one vacant cell, right? But we need 2 vacant cells. So that is why there is no use of pairing here. So the orbitals used here are 4s, 4p and 4d. Is the point clear? Even if you do a pairing here, we will get only one vacant orbital from 3d. But we need 2 vacant orbitals if you want d to sp3 hybridization. So that is why there is no pairing of electrons here and the 4d orbital is used. So it is an outer orbital complex. It is not an inner orbital complex. So this statement is also incorrect. So the correct statements are option A and option B. Okay, both the statements are correct. Okay, next question. Okay, from organometallic, which of the following is an organometallic compound? So there should be a bond between an organic compound and a metal. Those compounds are called as organometallic compound. The example is your metal carbonyls. Okay, they are the biggest example of organometallic compounds. Now you can see here, these are ionic compounds. These are also ionic compounds. And this is also ionic compound. But if you see this one is not an ionic compound. Okay, so this is your Grignard reagent, if you know. So Grignard reagents are organometallic compounds. Correct answer for this question is option B. Okay, next. CO is a stronger field ligand. Why? Because it has back bonding. It can give electrons. It can also accept electrons due to pi back bonding. So the correct answer for this question is option B. Okay, so this question has come from your color concept, which is very, very important. See, let us see the question. Okay, though we have got 3 products. Okay, this part you can read. Didentate ligand is progressively added with the molar concentration 1:1, 2:1, 3:1, and these compounds have formed. The wavelength in nanometer of light absorbed in case of 1 and 3. Okay, so which light range they have absorbed, that is the question. Here we should know we have complementary color system, that is V, B, G, we have Y, O and R. And I'll also tell you the wavelength. Okay, so red around is 700, this is 650, 600, then we have 550, 500, this one is 450 to 400. There's not the exact value, some ranges I'm telling. Now the color of this compound, the third compound you can check. First compound, this compound is pale blue and this compound is violet, right? The third compound is violet in color. So if it appears to you as violet, it will be accepting range, the wavelength it will accept will be for yellow range. Okay, so yellow comes and around 600. Okay, so we can see which options are nearer here. We can see 475 and 310 are far away. We can check these 2 options. Okay, now coming to this one, pale blue, right? Somewhere around pale blue, if it is observed as pale blue, it would have accepted in this range, orange yellow range, right? So if you see the color here, orange yellow, it is, yeah, this is 600, right? And 650, 600 range, but this range is very less. 310 is too less. So the correct answer for this question is option D. Okay, once again I'll repeat, little tricky question. You have to check for first and third what is the light they have absorbed. Now if the first compound is appearing as pale blue, it must have absorbed something in the range of yellow and orange. So yellow and orange lies between 600 to 650. So the first compound must have absorbed the radiation of this wavelength. Now coming to the second part, it is visible as blue, right? So it will be absorbing someone around yellow range again. So if you see, it comes in between somewhere here, like near to the answer. Not, I'll tell this part is correct. This part is some approximation value. So the appropriate answer for this question will be option D, because all other options, the A part you can eliminate, right? Okay, so that's all for this. We have discussed all the important questions from coordination chemistry. If you are able to do these type of questions, you can assure that this chapter is ready for your exam. And if you have doubt in any question, you can comment it. I'll take it in my next video, definitely. So if you have found this video informative, please like, share and subscribe our channel.